Okay, so our last section here is doing quadratic word problems. Most of these are set up in a way that we already are familiar with, and we just need to use what we've learned in this chapter to finish the equations at the end. So the first one, an altitude measures 2 centimeters less than twice the length of its base. So for a problem like this, it makes sense to let the base be x, because the altitude is described in the base. And so that means the altitude, so if x equals the base, so remember in all these, always define your variables, then 2x minus 2 equals the altitude. And so it says if the triangle is an area of 6 centimeters, so we need to remember the area formula, which is area equals 1/2 base times altitude, or height. Now we have a quadratic equation that we need to solve. I'm going to go ahead and multiply both sides by 2 to get rid of the 1/2, and then multiply this out. So I get 2x squared minus 2x equals 12. And so that gives me this quadratic equation, 2x squared minus 2x minus 12 equals 0. With a quadratic equation, it's always okay to simplify things by dividing through by a number. And so I'm going to divide everything by 2 to get this. And then I've got to decide, all right, how do I solve this quadratic? Well, this one looks factorable to me, and so I'm going to start by trying to factor. And it does turn out that I can factor it, so x is either going to equal 3 or -2. It can't equal -2 because x was the base, and a length has to be positive, and so the correct answer here is 3. If the base is 3, the height would be 3 times 2 minus 2, which would be 4. 3 times 4 times 1/2 is 6. Yes, that is correct. For number 2, it says find two positive integers whose difference is 4 and the sum of whose squares is 106. This one, I'm just going to let x and y be the two integers, because I don't have an easy way to write one in terms of the other to start with. And so that means that we have the difference of the two is 4, so we'll make x the bigger one. So x minus y equals 4. The sum of their squares is 106, so x squared plus y squared equals 106. That means that this is x is going to be y plus 4, so we can do a simple substitution to solve this equation. And so we take the x and we substitute it in there. And so that gives me y plus 4 squared plus y squared equals 106. I need to multiply out this. So a binomial squared is just the first term squared plus 2 times their product. 4 times y times 2 is 8y plus 16 plus y squared equals 106. Subtract the 106 and combine like terms gives me 2y squared plus 8y minus 90, right? 16 minus 106. Like the last problem, I can divide through by 2. And I get y squared plus 4y minus 45. So then I try to factor like I did on the last one. It does turn out to factor. And so I get y equals -9 or y equals 5. Y can't equal -9 because the beginning of the problem says two positive integers. You always need to go back and check your answer against the nature of the problem. Does your answer violate something in the problem at any point? So the -9 does, but 5 does not. And so the answer, the two positive integers, is 5. And then, well, what minus 5 equals 4? That would be 9. And so 5 and 9 are the two positive integers that solve this problem. 25 plus 81 does equal 106. Okay, for number 3, the Parks Commission wants a new rectangular sign with an area of 25 meters squared for the visitor centers. The length of the sign is to be 4 meters more than the width. And so we can say W equals width, W plus 4 equals length. And it just says the area has to be 25, so our equation is very simple. Length times width, because it's a rectangle, equals 25. So W squared plus 4W equals 25. W squared plus 4W minus 25 equals 0. This one does not factor. 25 doesn't have a lot of factors that go into it, so we don't have integer solutions here that we can easily see. So we have to decide what to do. You could either do completing the square or quadratic formula. I'm just going to do the quadratic formula, and so that means W is going to equal a negative B, so negative 4, plus or minus square root of B squared, which is 16, minus 4 times 1 times C, which is 25, or negative 25, all over 2, which gives us negative 4 plus or minus square root of, well, that turns out to be 116, right? Negative 4 times negative 25 is positive 100, all over 2. It says, give the answer to the nearest tenth of a meter, so I don't need to simplify the radical because I'm just going to type it into my calculator. I do notice on this one that I don't want to do the minus because that would give me a negative value, and W needs to be positive. So in my calculator, all I need to do is a negative 4 plus the square root of 116, which gives me 6.77, divided by 2, it gives me 3.38. And so it says round to the nearest tenth of a meter, and so that's going to give me 3.4 meters. And so what are the dimensions of the sign? 3.4 by, well, 3.4 plus 4 is 7.4. And that gives me the answer. You can type that into your calculator. So you'd have your answer times your answer plus 4. And that should give you exactly 25. And so 3.385164007 plus 7.38 does equal 25. And so I know my answer is correct. Again, the negative you don't need to use. All right, 4 is another one of these kite problems. And so it says a rectangular picture is 5 centimeters longer than it is wide. So we know that W equals width. W plus 5 equals length. For this one, because it's a frame problem, I'm going to draw it. And so it's going to have a picture that is W and then W plus 5. And then it says the frame is a uniform width of 2 centimeters. Remember, that means this is 2 and this is 2. And then this is 2 and this is 2. So that means that this side would be W plus 4. 2 plus W plus 2 gives you W plus 4. And this would be W plus 9, because 2 plus W plus 5 plus 2 gives you W plus 9. It says if the area of the picture, so the area of the picture is W times W plus 5, this is the picture, is half the total area, where the total area is W plus 4 times W plus 9. That's the area of the frame and the picture together, the total area. It says, what are the dimensions of the frame? So we need to solve this. To solve this, it's going to be way easier to think of it, get rid of that 1/2 and bring the 2 over here. I'm just multiplying both sides by 2. So that's going to give me 2W squared plus 10W equals, this one's going to be what? W squared, 4W plus 9W is 13W plus 36. Solve this quadratic by collecting all the terms on one side. So let's subtract all these this right side, so that gives me W squared minus 3W, right? Subtract the W squared from 2W, 13W from 10W, and then minus 36 equals 0. We can mess around and try to factor this a little bit, because it kind of looks factorable, but it turns out that it is not factorable. So again, we're going to apply the quadratic formula. So W equals negative B, 3 plus or minus square root of B squared, which would be negative 3 squared, which is 9. Minus 4 times 1 times negative 36, all over 2. 2 times 1, A is 1. And so that gives me 3 plus or minus square root of, well, 9 plus 144, so 153 over 2. Again, this can be factored if your answer was supposed to be in simplest radical form, but it says round to the nearest tenth, and so we don't need to factor it. Also, square root of 153 is somewhere a little bit above 12, so 3 minus 12 is not going to be a solution. So we only have to do the positive like we did on the last problem. So 3 plus the square root of 153 gives me 15.3693168 divided by 2. And we find out that the width would be 7.7, which means the length is going to be just 5 more than that, and that is 12.7. So 7.7 and 12.7 are going to be your answers. All right, for the last one, this is a work problem. It's talking about Mr. T and Mr. Keith. It looks like Mr. T takes 20 minutes longer than Mr. Keith does. And so X would be, it's already defined as the amount of time it takes for Mr. Keith. And so X plus 20 is Mr. T's time. And it says together, they take 25 minutes. Well, if you remember, there's a couple ways to do this. The way I like to do it is the amount that Mr. T gets done in 1 hour plus the amount that Mr. Keith gets done in 1 hour equals the amount they get done together in 1 hour. So Mr. Keith does 1 over X. That's how much he can get done in 1 hour. And so he just does 1/20th. If it's 20 minutes, or 1 minute actually is what we're going to be doing, because this is in minutes. He does 1/20th of his job in 1 minute, because it takes him 25, or 1x over. If it was 10 minutes, it'd take him 1/10. If it was 50 minutes, it'd be 1/50th. So 1 over X. Mr. T is going to be 1 over X plus 20. And then together, they're going to get 1/25th of the job done per minute. So this is our equation that we need to solve. So we need to clear those denominators. And so it's a lot going on here. So the X cancels, and that leaves us with 25 times X plus 25. The X plus, actually times X plus 20. The X plus 20 cancels, and that's going to leave us with 25X. And then the 25 cancels, and that leaves us with X times X plus 20. And so this is our quadratic to solve. We get 25X plus 500 plus 25X equals X squared plus 20X. Collecting everything over here, we get our quadratic as X squared. Subtract 50X, so that gives me minus 30X. And then subtract 500. This one doesn't tell you if it should be simplest radical form or nearest tenth. And so you should give us an exact answer. Always give exact if it doesn't tell you which one. So it doesn't factor. And so we're going to use quadratic formula. Negative b plus or minus b squared minus 4 times 1 times 500 all over 2. So that gives me 30 plus or minus square root of, well, this is going to be 900 minus 2,000, or plus 2,000. And so that's going to give us 2,900 all over 2. We don't need the negative because our time can't be negative, and 2,900 square root of 2,900 is greater than 30. The nice thing is that simplifies pretty easy to just 10 root 29, because 100 goes into there and 29 is prime. Get rid of the 2 by dividing everything by 2, and you get 15 plus 5 root 29 is how many minutes it would take Mr. Keith to grade the test, and then obviously Mr. T is 20 minutes longer than that.